Hi there, welcome to this video. My name's John. I provide tuition and support for A-level maths, A-level further maths, including 6-term examination papers and mathematics admissions test. Very warm welcome to this video where we're going to take a look at quadratic inequalities, how to solve quadratic inequalities effectively. Why have I chosen to do this in this topic in this particular video? Well, from my personal experience dealing with A-level maths students, solving quadratic inequalities is something that is consistently done very badly by A-level maths students. Not all, obviously not all, some are perfectly capable of solving quadratic inequalities, but very many A-level maths students are not very good at solving quadratic inequalities. And what it comes down to, in my opinion, in my experience, is a fundamental lack of understanding about how to properly interpret the information in an inequality, in this case a quadratic inequality. So there's different ways that you can interpret the information. So usually your inequality will be given to you in an algebraic form, might be given in a wordy kind of form, but typically it's going to be kind of an algebraic form. So you might have something like, I don't know, x squared minus 2x minus 3 is greater than 0, for example. Now the mistake that a lot of people make is that because the information is presented in an algebraic form, they think that they have to take a purely algebraic approach to solving this. Now that's possible. It's possible to take a purely algebraic approach to solving this quadratic inequality, and there's nothing wrong with that, provided that you know what you're doing. Okay? If you know what you're doing, fine. But there are certain difficulties that a lot of A-level students will run into when they try to take a purely algebraic approach to solving a quadratic inequality such as this, which I'll talk about later in the video. So the information contained in this inequality and what you're being asked to find effectively can be thought about in different ways, algebraic and geometric, for example. These are the two main ways that we're going to interpret the information. And it's not one or the other, it could be both, right? It might pay for you to think about this in both an algebraic sense and a geometric sense. Even though you're not specifically instructed to do one or the other, it pays for you to be able to do this. Because if you can interpret information in a variety of different ways, what you'll find is that information is easier to process in a certain form than another form. But so, for example, you might have an algebraic interpretation of this, you might have a geometric interpretation. It might be easier for you to see certain things in a geometric interpretation than the algebraic interpretation, and vice versa. And if you know how to translate those bits of information from algebraic to geometric and geometric to algebraic, then you get the best of both worlds, because you can mesh these two approaches together, and you might find that you much more easily find solutions to problems, because you can see things going on in the geometry, in the diagram, that you can interpret in an algebraic sense. You can represent it in an algebraic sense. You can do certain calculations, and then that tells you more about what's going on in the diagram that you can't necessarily just see from looking at the diagram. So it's very useful to be able to do this, and unfortunately it's something that a lot of A-level students struggle with. And it's not because they lack intelligence. It's not because they're not smart enough. It's just that they don't spend the time familiarizing themselves with these connections between the different representations, the different interpretations of information. And it's not that they haven't been told about them as well. They've definitely been told about them. It's just that they haven't spent the time thinking about these things, thinking them through, and really seeing how these bits of information connect together. And this is much to their detriment, okay? So if I were to solve this quadratic inequality, I would be very tempted to look at this primarily in a geometric sense. Why? Well, because that's my preferred way of going about it. But because it gives me personally the best opportunity, the best chance of getting the correct solution sets to this quadratic inequality. So what I say in this video is not me saying you have to solve quadratic inequalities in this way or that way or the other way, otherwise you're not going to get your marks or anything like that. There's all sorts of ways that you can solve quadratic inequalities. And as long as you choose a valid way that's logically sound and you get the right solution, then you'll get your marks, whatever, right? I'm just going to give you an idea about how you might interpret this inequality, so that if you are having difficulty finding solutions to quadratic inequalities, you might see that there is actually a very easy way that you can find the solutions to quadratic inequalities. Now, this is not me saying that I'm trying to deprive you of your responsibility of understanding. That's not what this video is about. To get the most out of this video, you still need to make sure that you understand what I'm doing to a certain extent, which means that you might have to think carefully about what I'm doing and why I'm doing it. Now, I will explain as much as I can, but I can't make anybody understand. I can explain until I'm blue in the face, but unless you choose to take it upon yourself to try to understand, then you probably will never understand. And that is your responsibility, to make sure that you take the time to make sure that you understand. Now, that doesn't mean that you can't ask questions. If I say something that's not clear, ask the question in the comments section to this video. Okay? That's what I'm here to do, to try to clarify things. But ultimately, it falls on your head to make sure that you find ways in your own minds to understand the concepts and ideas that you introduce to. Okay? Don't expect that just somebody telling you about something is going to suffice. There's a very big difference between knowing something and understanding it. Okay, so if I were to solve this quadratic inequality, I would straight away, almost automatically, start to think about the graph of this quadratic equation. Y equals x squared minus 2x minus 3. Okay, why? Why would I do this? Well, that's what I'm going to show you. So what I want to do is to sketch the graph of this. And it is a sketch. You don't need graph paper, anything like that. We need a sketch. So this is part of your A-level course, sketching graphs of quadratic equations, or quadratic functions, sorry. You do need to be able to do this. It's not difficult. You need to be able to do it, okay? So, I mean, there's different sets of circumstances that you might find yourself in. So some quadratic functions have real roots, some don't, okay? We're interested in this video in the case where we've got real roots. We're not interested in complex roots and things like that. We're sticking with real numbers, not going into complex or imaginary numbers in this video. So to sketch the graph of this, I might look for the roots. Okay, that might mean that I use factorization or quadratic formula, whichever is appropriate. Okay, if I suspect that this doesn't have roots for whatever reason, then I might check the discriminant first. But if I'm solving a quadratic inequality, usually it only really makes sense to do that if there's roots. Okay, as we'll see, it can happen where you're trying to solve a quadratic inequality for a quadratic expression that doesn't actually have real roots, for example, but it's kind of a trivial case. We're not really interested in that too much. So this does have roots, and I can find them by factorization. X minus 3, x plus 1. Solving the equation x minus 3, x plus 1 is equal to 0, because this is the factorization of x squared minus 2x minus 3. So the roots are going to be x equals 3 or x equals minus 1. Okay, hopefully you're comfortable with solving quadratic equations via factorization. Right, so why is that useful? Let's have a look. If I draw the graph now of y equals x squared minus 2x minus 3, this is a positive quadratic. So its graph is going to look something like that. Now, how much information I include in my graph is entirely up to me. This is something that I'm doing to help me. It's not necessarily something that I've been specifically instructed to do. And please understand this, that just because you haven't been specifically instructed to draw the graph of this quadratic doesn't mean that it's not worthwhile doing this. This is another thing that a lot of A-level students seem to get into their heads, is that if they haven't been specifically told to do something, then they're wasting their time by doing it, because there's no marks available for it. And this is just not true at all. Okay, by denying yourself, by not drawing the graph of this quadratic, you may be denying yourself the opportunity to actually solve this quadratic inequality. You may be, you may not be. So even though you might not specifically get marks for drawing the graph, you will not get the mark if you don't solve this quadratic inequality properly. Then you can be sure that you will not get your marks. Whereas in some cases, if you drew this graph and got the solutions to this quadratic inequality, you might get your marks for the solution to the correct solution, but you might not specifically get marks for drawing the graph. Okay, I mean, these kinds of things can happen, but don't think that just because you haven't been specifically instructed to do this, that you shouldn't be doing it. It's not worthwhile. So the roots are 3 minus 1. I could find where it goes through the y-axis. If I think it's going to be useful to me, I could find the coordinates of the vertex. If I think it's going to be useful to me, this information right now is probably not going to be that useful to me. Okay, so there's different parts of this graph that I can focus on now. There's the parts of the graph that are above the x-axis, there's the parts of the graph that are on the x-axis, and there's the parts of the graph that are below the x-axis. So there are certain values of x that correspond to points on the graph that are above the x-axis. There are certain parts of the graph, certain values of x that correspond to those parts of the graph that are on the x-axis, and similarly for below the x-axis. So let's take one of these parts that we see that is above the x-axis. What are the coordinates of this? How can we write the coordinates of this point? Well, generally, if we've got y equals f of x, we write the coordinates of a point on the graph of y equals f of x as x, f of x, right? So what is f of x here? It's x squared minus 2x minus 3. Now this point is above the x-axis. So what can we say about its y-coordinate? Its y-coordinate must be greater than 0. Okay. What about the points down here? Do a similar thing. X squared minus 2x minus 3. What can I say about the y-coordinate of this point? Considering that it's below the x-axis, it must be less than 0. What about this point here? We've got x squared minus 2x minus 3. At this point, which is on the x-axis, the y-coordinate is going to be equal to 0. Okay, why is this useful to me? Because this effectively is asking me for those values of x which correspond to points on the graph of y equals x squared minus 2x minus 3, which are above the x-axis. Okay, so that's how I would interpret this. Those values of x for which the graph of y equals x squared minus 2x minus 3 is above the x-axis. Okay? So I can interpret this in words, in plain English, and then that might make it much easier for me to interpret which information I need to extract from this diagram. So having these different ways of representing this information really works to my advantage here, because I can bounce these interpretations off each other and get the information that I need. And it's much easier for me to get the information that I need. Now you might say, well, this is a lot of work to do. It's really not. Okay, maybe the first couple of times you go through this and you've got to think about it very carefully. Yeah, it might take a little bit longer for you to do, but just like any skill, you learn to play guitar, for example. What's it like the first time you try to learn to play guitar? Well, your fingers are all over the place, and you've got to actually physically put your fingers in the right place with your other hands sometimes. And it takes you ages to get your hand in position for a chord, but after a couple of weeks of practicing, what happens? You're changing chords, you're singing along, you're not even thinking about it. You're just having fun, right? Okay, maybe you're not going to have so much fun solving quadratic inequalities, but you can still make it kind of second nature, right? It's really nothing to solve a quadratic equation and draw its graph. If it is a big deal for you, that suggests that you've really not done enough practice with it. And that's something that you need to fix, really. There's no excuse at A level for not being able to deal with quadratic equations. Okay, so Similarly, I could change this inequality to less than, and this is going to tell me to look for those values of x for which the graph of y equals x squared minus 2x minus 3 is not above, but below the x-axis. I might even change it to x squared minus 2x minus 3 is less than or equal to 0, in which case I might change this then to those values of x for which the graph of y equals x squared minus 2x minus 3 is on or below the x-axis. Again, being able to interpret this in words is telling me exactly what to look for over here, but still I need to understand why these bits of information all fit together in the way that they do. Not just that they do fit together, but why they fit together in the way that they do. Okay, very important. So that's the way that I would go about solving a quadratic inequality. So what would this, I've changed it now, but what would the solution to this quadratic inequality be, the one that we started with? Well, it would be x is greater than 3 or x is less than minus 1. Okay, I can see that for values of x greater than 3, we get points, correspond to points that are above the x-axis. Change it to less than or equal to 0. What do I get? Well, that's the points that are on or below the x-axis. So it's these values of x in here. So minus 1 less than or equal to x is less than or equal to 3. Easy. Okay. So not only do I get the solution to this quadratic inequality, but basically any other quadratic, whatever symbol you put in here, inequality symbol that you put in here, you can read off the solution from this diagram. So you're getting all this extra information. Right, so what are some of the problems that you might run into if you take a purely algebraic approach to trying to solve this quadratic inequality? Let's have a look. So this is, I don't necessarily say don't do this, but if you're going to take a purely algebraic approach to solving quadratic inequalities, just be on your guard, okay? Know what you're doing. So, let's say we've got x squared, what was it? X squared minus 2x minus 3 is greater than 0. So we know what the solutions to this are. And we're going to compare it to x squared minus 2x minus 3 is equal to 0, the solution to this equation. So this is where people go wrong, because they try to copy what they do here, right? You know, what you do to solve this quadratic equation, they try to kind of copy that and try to do what they see as the analogous thing over here, and it leads them into error. And it's purely because, I hate to say it, they don't understand what they're doing when they're solving this quadratic equation, or they don't understand thoroughly enough. I'm not saying that they don't know how to solve this, it's just that they know which steps to go through, but they don't understand why they're taking the steps that they are taking. And this is a big thing that will really discriminate between those people that typically get high marks on an exam and are successful at mathematics and seem to do really well, make a lot of progress, and those people that seem to lag behind. They might get reasonably high marks, but they never really get to above a certain level. And what it often comes down to is how well do you understand what you're doing? And understanding is not the same as knowing. Knowing how to solve a quadratic equation is not the same as understanding how to solve a quadratic equation, as I'll explain. So let's say we want to solve this, then we might use factorization. We get x minus 3, x plus 1 equals 0. So this, therefore, we're told means that x minus 3 equals 0 or x plus 1 equals 0, and therefore x equals 3 or x equals minus 1. Okay? So this is the step where a lot of people lose their understanding. In fact, well, a lot of people lose their understanding going from here to here as well. But this is something that, for a lot of people, this is just what you do, right? This is what you do to solve a quadratic equation, but there's no real understanding as to why you do this. So what that results in is them trying to take this and replacing these equality symbols with the inequality symbol to end up with something like this. X minus 3, x plus 1 greater than 0. I'm going to put some big exclamation marks here because this is totally and utterly wrong. So that leads them to think, using the kind of analogous argument to this, that x minus 3 is greater than 0 and x plus 1 is greater than 0. So that means that x is greater than 3 or x is greater than minus 1. But we know that the solution to this is x is greater than 3 or x is less than minus 1. We've seen that from the diagram. So what's gone wrong here? We seem to have got this bit right, but this bit wrong. What's happened? Well, it's come from trying to copy this approach too closely without understanding it. What's going on? Okay. How does this work? Very important. It's very important that you understand that when you're dealing with algebraic expressions like x minus 3 and x plus 1, these are effectively numbers for all intents and purposes. They're just not specified. Numbers that are specified, or they're unknown. Okay? But for all intents and purposes, they're still numbers. They behave like numbers as far as we're concerned. So we're multiplying two numbers together here, x minus 3 and x plus 1. Okay? And the product of those two numbers, those two real numbers, not that it makes that much difference, is equal to 0. So what does that tell us? Well, the only way that we can multiply two numbers together and get 0 is if one of those numbers is equal to 0 or both of those numbers are equal to 0. It's not possible to multiply two non-zero numbers together to get 0. Try it. So either x minus 3 equals 0 and or, although it's the or in this case, x plus 1 equals 0. Right? Which justifies the step from here to here. We've got to consider both possibilities. And therefore, x equals 3. If x minus 3 equals 0, then x must be equal to 3. X plus 1 equals 0. X equals minus 1. But the same doesn't apply over here. Right? The same does not apply over here. So here we needed at least one of these to be equal to 0. But what about here? X minus 3 times x plus 1 is greater than 0. Does that mean that we need at least one of these numbers to be greater than 0? The answer to that is no. We could have two negative numbers multiplied together to give a number that's greater than 0. Minus 2 times minus 4 is equal to 8. Both of those numbers are less than 0, but multiplied together, you get a product that is greater than 0. So this is wrong. It's unfortunately incomplete. To make this work, if you were going to do this, if you're going to take this approach, what you would have to do is you would have to consider, right, if x minus 3 is greater than 0, that means that x plus 1 is also going to have to be greater than 0. So this is not an or, this is an and. And similarly, if x plus 1, you're going to have to consider another case, which is x minus 3 is less than 0 and x plus 1 is less than 0. Right? So there's a bit more work that you've got to do here. So if x minus 3 is greater than 0, let's have a look. That means that x is greater than 3 and x is greater than minus 1, which means that x must be greater than 3. Okay? We take this, x minus 3 is less than 0. That means that x is less than 3 and x is less than minus 1, which means that x must be less than minus 1. Right? If it's got to be less than 3 and less than minus 1, it's got to be less than minus 1, because it's got to satisfy both of these inequalities. That's what we get. X is greater than 3, x is less than minus 1. So you want to take an algebraic approach to this, you can do. To solving this quadratic inequality, you can do, but you're going to have to be much more careful, and you're going to have to understand what it is that you're doing. It doesn't suffice for you to just try to copy what you've done here with the quadratic equation, because you're going to be drawn into error. Okay, this applies to all of the mathematics that you do. You need to understand as much as possible. It doesn't suffice for you to just know how to do things. You need to understand as thoroughly as possible. And this means that you've got to be kind of inquisitive. Now, obviously, I understand that not everybody is terribly interested in mathematics. A lot of people just want to get the job done. So it's natural for these people to try to take shortcuts and things like, we all do it. I do it for things that I don't really want to do. You try to take shortcuts. The result is that, unfortunately, the shortcuts that you try to take just don't work. Okay, I know that you're still going to do them, because I still do that after all these years. You still think that, oh, I can just take a shot. I don't really want to do this, so I'll try to take a shot. And it just ends up taking longer, ultimately. So if you can at all avoid that temptation, easier said than done. I'd be lying if I said that I didn't do this from time to time. Try to avoid the temptation of just kind of trying to rote memorize everything and just copy what your teacher does. Really try to get to an understanding, because it's only through understanding that you're really going to be able to solve problems in mathematics, including the genuine problems that are likely to come up on your exams. Okay, so on your exam, of course, you'll get routine calculations and things that you need to do. But then you'll get genuine unseen problems. Okay, well, if you don't understand, if you lack understanding, you're really going to find it difficult, if not impossible, to attack those genuine unseen problems. Okay, so, that's all I've got to say on quadratic inequalities in this video. If there is anything that you'd like to add, anything that you would like to ask, leave a comment in the comments section. I do make these videos for free. I don't get paid for making any of these videos. If you do get some benefit from these videos, please hit the subscribe button, show your support for this channel, and hit the like button, because I would like to continue making these videos. I really do want to, as much as possible, help people prepare for their maths studies, their maths exams and things like that, and really help them to reach their true potential. But it's only worthwhile me doing this while there are people who are actually benefiting from my work. So if you would like me to continue making these videos, then please show your support for this channel by hitting the subscribe button, leaving a nice comment in the comments section, and sharing these videos with other people that you think might benefit from them. If you do have any criticisms of the videos, if there's anything that you would like to see done better, again, leave a comment in the comments section. Constructive criticism is useful. Please don't just leave a comment saying your video's crap. Okay, if you think it's crap, tell me why you think it's crap so I can do something about it. Okay, I've got no problem with you telling me that my work is crap, but please tell me specifically why you think it's crap. Okay, so I'm going to leave the video there. I say thank you very much for watching right to the end. If you made it to the end, congratulations. And hopefully I'll be uploading plenty more videos to my channel, so please keep an eye out for any new videos that do crop up. And without further ado, I'll say thank you for watching, and I'll see you in the next video.